All right, folks, welcome to lesson 5-4, solving radical equations and inequalities, part 2. So this is going to build upon the previous lesson that we just did last class, and we're going to get into some more complicated radical equations. So let's take a look at the first problem. In this problem, we have the square root of x plus 6 plus 1 equals the square root of 7 minus x. Wow. Okay, so what you'll see here is we don't just have, like we did in the last section, a radical on one side and stuff not underneath a radical on the other side. In this case, we have a radical on both sides, but we also have this number that's not underneath a radical, and we're going to have to deal with that. We're going to have to deal with this plus 1 right here. So the question is, how in the world do I deal with that? Well, the answer is exactly the same as it was the last time. What we're going to do is we're going to take both sides and we're going to square both sides. So we're going to square the square root of x plus 6 plus 1, and we're going to square the square root of 7 minus x. Now, we got to be really careful. On the left-hand side, what does that mean? That means we have the square root of x plus 6 plus 1 times the square root of x plus 6 plus 1. We're going to have to FOIL on that side. But lucky for us, the right-hand side, the square and the square root kind of cancel each other out, and we're left with 7 minus x. So that actually works out really nice on the right-hand side, but on the left-hand side, we got to do a little work. So let's see here. We're going to take the square root of x plus 6 times the square root of x plus 6. That just gives me x plus 6. So the squared root kind of cancels out when I multiply it by itself. It's almost like it's squaring it like we did on the right side, but it cancels itself out. So that's the firsts. Then we have the outside. So 1 times the square root of 6 is 1 square root of 6. And then we have the inside, 1 plus the square root of 6, which is, again, the square root of x plus 6. And then we have the last, positive 1 times positive 1, which is positive 1. Okay, so let's see here. On the left-hand side, we're going to have some like terms that we're going to be able to combine. So the x doesn't have any like terms, so we just have that. The plus 6 plus 1 gives me plus 7. And then the square root of 6 plus the square root of 6, that's 2 square roots of 6. And then we have the right side, which I'm just going to rewrite again. Okay, so now what? Well, now we have this radical here. We have this radical. So what we're going to do is we're going to isolate that radical. So what does that mean? That means we're going to move the x over to the other side, the 7 over to the other side. Let's see, what does that give me? That gives me 2 square roots of x plus 6 equals 7 minus 7 is 0. Negative x minus negative x is negative 2x. And then to continue isolating the radical, we're going to divide both sides by 2. What's that give me? That gives me the square root of x plus 6, and that gives me equals negative x. All right, so now we have isolated the radical. I'm going to need some more room, so I'm going to actually take my work up here. Let's see, we have the square root of x plus 6 equals negative x. All right, so what do? Well, I'm going to do exactly what I did to get rid of the radical in the last section. This is a problem we could have done from part 1 of section 5-4. So what we're going to do is we're going to square both sides. On the left-hand side, the squared and the square root cancel each other out. I'm left with x plus 6 equals, and negative x squared is just x squared. Okay, so now, again, just like we did in the last section, we have no radical. The radicals went away, and we have this like quadratic equation. See the x squared? That's what tells me we have a quadratic equation, this x squared that's right here. So now what am I going to do? Now I'm going to subtract x and subtract 6 because I want to get this thing set equal to 0. Remember, that's the only way we can solve a quadratic equation, is if it's set equal to 0, and then we can either use the quadratic formula or solve it by factoring. So I'm going to solve this guy by factoring because this factors nicely. Thank you very much. I get x minus 3 times x plus 2, which means x is equal to 3 and negative 2. Whew. All right, well, we're almost done with this problem. I just have to very quickly check the answers to see if they work out. So I almost ran out of room here. So let's see here. I have the square root of 3 plus 6 plus 1 equals the square root of 7 minus 3. Let's see here. That's the square root of 9 plus 1 equals the square root of 4. The square root of 9 is 3. 3 plus 1 equals 2. Uh-oh, this one does not work. So 3 is not a possible solution. Uh-oh. Let us check. Let me erase this. Let's check the other one. So let's see here, we'll do the same thing, but it's not a 3 anymore. It's going to be a -2. So let's try it with a -2 in there. So -2 and minus -2. So what do I end up with here? Let's see here. The square, -2 plus 6 is 4, plus 1 equals, let's see here, that's 3 minus -2, which is the same as 3 plus 2. So that gives me 9. And that's 2 plus 1 equals 3. Yes, it does work. So x equals -2 is the only solution to this particular problem. Wow, that took a while. Folks, you just got to be really careful when you're working through these problems. They are going to take a little longer and you're going to have to do a little more math. That's why I broke this up and we just did this in this particular section. Okay? As always, here are 2 example problems for you to work through. So I would like you to pause the video right now, take a look at these 2 problems, try them out, and see what you end up with. Go ahead, pause the video right now. Okay, so problem number 1. We have the square root of x plus 2 plus 1 equals the square root of 3 minus x. We're going to go through this problem and do exactly what we did in the last problem. We're going to square both sides. That will give me, if I multiply this out, so we have the square root of x plus 2 plus 1 times the square root of x plus 2 plus 1 equals, that just turns into 3 minus x. When we FOIL on this side, we end up with x plus 2 plus, I'm going to skip a step there, 2x plus 2 times the square root of x plus 2 plus 1 equals 3 minus x. I will combine my like terms, so I'll subtract x from both sides. I'll subtract 2 from both sides. What does that give me? Well, those cancel, and I'm left with 2 square roots of x plus 2 plus 1 equals, let's see here, that's going to give me 1 minus 2x. I forgot to subtract my 1 from both sides. I'll take care of that now. I'll get 2 times the square root of x plus 2 equals -2x. I'll divide both sides by 2, and I'm left with the square root of x plus 2 equals -x. This is almost like the last problem we did. All right, so I need some more room, so I'm going to take that up here. So here we have the square root of x plus 2 equals -x, and I'm going to square to get rid of the radical. Square both sides, so I have x plus 2 equals x squared. I'll subtract x, subtract 2 from both sides. That'll give me 0 equals x squared minus x minus 2. I have a quadratic, which I'll solve by factoring. End up with 0 equals x minus 2 plus 1. That gives me the values of 2 and -1 for x. I will go through the checking process, which I'm not going to bore you with here. And I'm going to figure out that 2 does not work. So the only answer is x is equal to -1. Go ahead and check it. Make sure you check it. I'm not showing it here. I ran out of space. That's no excuse, but you can do that on your own to check that problem. Let's take a look at number 2. Number 2, the square root of x plus 6 minus 2 equals the square root of x minus 2. Same idea. Square both sides. I'm going to skip that work here for you. I'm going to get x plus 6. In this case, when I FOIL it, I will get -4 square roots of x plus 6. Check your math. Make sure you get that. Plus 4 equals, that square and square root cancel out. Gives me x minus 2. Okay, I'll combine my like terms. Subtract x, subtract 6, subtract 4. I won't forget to do that this time. So that's here. That's -6 minus 4. Cancel, cancel, cancel over there on the left. I get -4 square roots of x plus 6 equals, let's see here. Oh, now that's interesting. In this problem, the x's cancel out. Okay, so I got -2 minus 6, which is -8, minus 4 gives me -12. Okay. Divide both sides by -4. Folks, you notice that the x canceling out didn't throw me off. The math did the work for me. So I'm not going to worry about that. That's not a concern of mine. I'm going to follow my algebra rules. And I'm going to say, man, thank you, because this problem is going to end up being a whole lot easier than the last problem I did. So I have the square root of x plus 6 equals 3, and I'm going to get rid of the radical by squaring both sides. And 3 squared is 9. I end up with x equals 3. Now, I'm going to check this. I'm going to plug it up into my original equation. So I have the square root of 3 plus 6 minus 2 equals the square root of 3 minus 2. That's 1 on the left-hand side, sorry, on the right-hand side. I get the square root of 9 minus 2, which is 3 minus 2 on the left. That does in fact work. So x equals 3 is my one and only one solution. Good job, Pod guys. Good job. For the next example, we're still solving, but now if you look, we have a fraction in the exponent. Now I don't want that to throw you all off. It's not gonna change anything that we do here in this particular problem, but I'll get to how we deal with the fractional exponent as we go through. But we have the quantity of 2x to the 3/4 power plus 2 equals 10. Okay, so first thing we want to do, remember this rational exponent that we have is really and means a radical. So this is like saying the fourth root, this is like the fourth root of 2x to the third power. And I don't want us to lose track of what that actually means. That's going to be important later on, okay? But for now, we're just going to forget about that. We'll forget all about that. I didn't even said anything about that. And we're going to isolate the radical, just like we did in the other problems. So if you remember that 3/4 power is like a radical, we're going to isolate it. How? We'll subtract 2 from both sides. So I have 2x to the 3/4 power equals 8. All right, now it's time to undo this exponent. Well, here's the trick. Here's the trick. What we're going to do is we're going to raise both sides to the 4/3 power. To the 4/3 power. Now, why to the 4/3 power? I want you to remember what the rule of exponents says. If you have a power raised to a power, like we do in this particular problem, you multiply the exponents. So we take 3/4 times 4/3. And what is 3/4 times 4/3? Well, that's 12/12, which is, guess what? 1. So what happens in this particular problem is we actually end up with this exponent canceling out. So by going through and doing this, we end up having these exponents cancel out. They all go away, and we're left with 2x equals, 8 to the 4/3 power. What is that? Well, if you remember, that is the same thing as saying the third root of 8 to the 4th power. The third root of 8 is 2, so that's really like 2 to the 4th power, and 2 to the 4th power is 16. Okay, so that actually works out really nicely because I end up with a really nice answer, and the math was easy to work out, and I leave x equals 8. Now, again, I'm going to check this. I'm going to plug it into my calculator. I'm going to make sure I end up with the correct answer, but if you're willing to trust me, this in fact does work. After I check it, you'll get an answer that works. This is not the only way we can do this problem. If you're not comfortable using the rational exponent, it's okay. Go back and make sure you view this as the fourth root of 2x to the third power. And if you go back and rewrite it as a radical, we can go through and do this just like we had been doing our other problems. Subtract 2 from both sides, and we end up with the fourth root of 2x to the third power equals 8. And then what you can do is you can go through and solve this by getting rid of this exponent. How do you get rid of something to the third power? You take the third root of both sides. The third root of 8 is 2. The third root and the third power cancel out. So I'm left with the fourth root of 2x equals 2. How do I get rid of the fourth root? I raise it to the 4th power. And then, like the exponent and the radical cancel out, I'm left with 2x equals 16. And I go through, do my last step, end up with the same answer I got, x equals 8. And again, make sure you check yourself. All right, next problem. 2 times the quantity of x minus 3 to the 2/3 power equals 32. Now, folks, you can go back and you can write this, again, this 2/3 as the third root of x minus 3 squared. I'm not going to. I like using the rational exponents. I think it makes the process just a little bit easier. It's a little less work. I can kind of condense some steps when I do it. And I think it's important that you understand how to use rational exponents to solve an expression. So I'm not going to do that with this problem. If you need to see it that way, I can show you on your own. But I'm going to go through and solve this problem using the rational exponent. So the first thing I want to do is I want to isolate the x minus 3 to the 2/3 power. I want to isolate that. So how am I going to do that? Well, the easiest way to do that is, of course, to divide both sides by 2. That gives me x minus 3 to the 2/3 power equals 16. Now what? Well, now, like I did in the last problem, I'm going to raise this to the 3/2 power. Now, 3/2 power. Remember, that's like the square root of this to the third power. So my rational exponents on the left side cancel out, and I'm left with just the x minus 3. But here's what's interesting. You need to remember that this number on the bottom, that is like taking the square root of both sides. Oh, So remember that that's like taking the square root of 16 and then raising the answer to the third power. And if you remember, whenever I take the square root of both sides, I need to have a plus or minus. That kind of creeped right up on us there. So I took the square root of 16, I got 4, plus or minus 4, and then I'm going to raise that to the third power. And plus or minus, positive 4 to the third power is 64, and negative 4 to the third power is 64. So I get plus or minus 64 on that. Now, the easiest way to remember when this happens is if this bottom number is ever even, if it's even, right? Then you need to remember a plus or minus, okay? In the last problem, if we go back and take a look at the last problem that we did, you will see that we took the third root of both sides when we solved. The third root, not the square root. 3 is odd. We didn't need to worry about a plus or minus in that particular problem. We do here. So what's this mean? We continue going on in the problem. We do one with a positive 64. We do the other with a negative 64, and we continue solving. We get x equals 67 and x equals negative 61. Now, trust me again, I'm going to check these. I'm going to plug these both back into my original equation, and you'll find out that they both, in fact, will work. So these are both answers to this particular equation. All right, so as always, here are 3 example problems for you to work through on your own. I want to remind you, whenever you're taking the square root, 4th root, 6th root, 8th root of both sides, you need a plus or minus. Don't forget that. Anytime that is an even root that you're taking it to both sides, you need a plus or minus. Don't forget about that. But I'd like you to pause the video right now, and I'd like you to try to work out these 3 problems. Good luck. All right, here's number 3. X plus 30 to the 1/2 power equals x. Okay, so we'll get rid of the 1/2 power by squaring both sides, right? The 1/2 times 2, they cancel out. That just gives me 1. So I have x plus 30 equals x squared. Oh man, quadratic-like equation. Okay, so set it equal to 0. So I get x squared minus x minus 30. And I factor this bad boy. I get x minus 6 times x plus 5. And I end up with the 2 answers of x equals 6 and x equals negative 5. I'm going to check them. I'll plug them back into the original equation if you trust me with this. Let's see here. If I go back, so 6 plus 30 is 36 to the 1/2. That's like the square root of 36, which is 6. And 6 does, in fact, equal 6. So that guy works. And negative 5. Negative 5 plus 30 is 25. The square root of 25 is 5. That does not equal negative 5. So negative 5 does not work. It won't work in this particular problem. The only solution is x equals 6. The next problem, number 4. X plus 2, that quantity to the 3/4 power equals 8. Okay, so what am I going to do? I'm going to raise both sides to the 4/3 power. Whoops, I can't write that and say it. It's to the 4/3 power. Okay, so notice this number right here, the bottom, the 3 that's on the denominator means I'm taking the third root of both sides. No need to worry about the plus or minus. Just want to remind you of that, so we don't need to worry about it in this problem. Okay, let's keep going. 3/4 times 4/3, they cancel out. I'm left with x plus 2 equals, okay, so this is the third root of 8 to the 4th power. The third root of 8 is 2. 2 to the 4th is 16. I'm left with x equals 14. When I solve this, I'll plug 14 back into the original problem. It will, in fact, work. So 14, x equals 14 is the solution to this problem. Last one to go. We have the quantity of 2x minus 3 to the 2/3 power plus 4 equals 13. All right, first thing, I got to get rid of this 4. So let's subtract 4 from both sides. That gives me 2x minus 3 to the 2/3 power equals 13 minus 4 is 9. Okay, now I'll raise both sides to the 3/2 power. Okay, now this is a part, right? That's a 2. That's a 2. So we need to remember the plus or minus. Okay, so on the left-hand side, I do end up with just 2x minus 3. But on the right-hand side, I got to remember, this is the square root of 9 to the 3rd power. Don't forget the plus or minus. Okay, so the square root of 9 is 3. 3 to the 3rd power is 27. So I end up with plus or minus 27. And now it's to split this problem into 2. So I get 2x minus 3 equals positive 27, and 2x minus 3 equals negative 27. I'll solve them individually. So let's see, that's plus 3, gives me 30, got 2x, so x equals 15 is one solution, and the other, I'll add 3 to both sides, That gives me 2x equals negative 24. So here, x equals negative 12. Okay, so then I'll check them. I'll plug both of these back into the original equation, and guess what? They will both, in fact, work. So I do have two answers for this particular problem. They will both work when I plug them back in. So that's lesson 5.4, part 2. Good luck with these problems. Just remember, take your time, make sure you're following all your rules of algebra, and you will be successful with these. I'll see you soon.